Step-by-step exam solutions. Okay, math class, training you to excel. Subscribe to step-by-step exam solution. Like the video. Share the link of this video with others. Click for notification so that you'll be alerted when the next video is released. Please drop your comment for a better service. 5 steps to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, perform. These are 5 good steps to succeed in any examination. Okay, math class, present step-by-step exam solution to the determinants of a matrix. The determinant of a matrix. In this presentation, we'll be studying the following content. Number 1, the physical meaning of a determinant. Number 2, the determinant of a 2 by 2 matrix. And number 3, the determinant of a 3 by 3 matrix. The objective of our presentation are: number 1, define and state the physical meaning of a determinant. Number 2, calculate the determinant of a 2 by 2 matrix. Number 3, calculate the determinant of a 3 by 3 matrix. Let's go to the next slide for the discussion and the presentation proper. The first thing we're looking at is the determinant of a matrix. What actually is the determinant? The determinant of a square matrix is a scalar or a number that shows how a matrix does the following things. Number 1, reshapes space. Number 2, scales volume or scaling volume. Number 3, flipping orientation. Number 4, indicating whether a transformation is reversible or not reversible. These are the information that are coded in a determinant. Number 1, we talk about reshaping space, talk about volume. Now, dealing with volume, we are dealing with the determinant of a 3 by 3 matrix. And dealing with area, surface, plane, we are dealing with a determinant of 2 by 2 matrix. That's scaling volume, reshaping shapes, flipping orientation. In mathematics, we know we have translation, you have rotation, you have reflection. These are different orientations. So the matrices help us to flip this rotation. Know when it's translation, reflection, or rotation, or stretching or compression. These are the things matrices help us to do. The inversion of also matrices are very important in science and medical practice. So that's to tell us that what we are studying today is very important. So therefore, the determinant is represented, as you can see here. The determinant of a matrix is represented. Let's say the matrix is A. Then the determinant is represented by what you are seeing there now. You see the first one there. The first one you see here is using this or this. And another one we can use also to represent determinant is this triangle. All of the above represent determinant of a given matrix. So there are 3 notations. Either you put the capital letter in a parallel bracket like that, or you write det A, or you can use delta, the triangle, to represent a determinant. So now, for a 2 by 2 matrix, the matrix A is given by this 2 by 2, having the following elements: A, B, C, D. The determinant A, the determinant of this matrix A is given by this. How do we get that? Very important. Please pay attention. Now, What you notice here is that this AD is the multiplication or the product of the main diagonal or the leading diagonal. That's AD. So this AD is obtained by multiplying the elements of the leading diagonal. Now, after that, that is positive. Then the opposite direction, the second diagonal, the product of that second diagonal is BC, and that gives us the answer we get when we multiply the second diagonal. So that gives us a simple definition of 2 by 2 matrix. The magnitude of that matrix is obtained by performing this operation. Now let's look at this. For the determinant A, we have that 2 by 2 matrix like that, and then that will multiply that, the product of the leading or the main diagonal, and then that's the product of what? The second diagonal. So now let's now solve some problem. Let's do some calculations. Now we have given a matrix A with the element, as you can see clearly. The question says you should find the determinant of A. Find that A. So now we start to solve the problem. Now the determinant of A, as I said, is given by this definition we're having here now. So now we have determinant of A is now given by that. So remember that these lines represent, these lines you are seeing here represent, these lines here represent determinant. But when we use this, it means matrix. When we use this, it means determinant. So please take note of that. That's the difference between determinant and matrix so that you don't mix them up. So now if I multiply the leading diagonal, so what do you see? That multiplication will give me an answer. What is the answer? 6. And that direction, because the sign of this is positive, the next sign should be negative, not this minus. That's the alternating the sign to find the cofactors. So now, then the second diagonal, we are going to multiply the second diagonal. So now, remember, this position is minus, but there is minus in this answer. So you are going to have 1 times minus 3. The answer is minus 3. But because the direction of the second diagonal is minus, they have minus 3 will give us plus. So now you have plus 3. So now if you add them, you now have the determinant of this matrix is what? 9. So the determinant of this matrix is 9. For a 2 by 2 matrix, the determinant gives the area of the transformed unit square. I mentioned it before, how it transforms space. It gives us the area of the transformed unit square. So you see that in vectors, you see that in matrices, you see that in other advanced mathematics. So now that's number 1. Number 2, for a 3 by 3 matrix, it is the volume of the transformed unit cube. Now, when the determinant of a matrix is 0, what is the mathematical and scientific implication? It just means no space. The space is completely collapsed. No volume, no inversion. So therefore, when the determinant of a matrix is 0, that matrix should not have an inverse because there will be no invertibility. Do you get that? So that's why when the determinant is 0, the matrix has no inverse. That's the reason. Now I've told you the reason. You put down somewhere in your notebook so that you don't forget. Even in the university, this particular video will be very essential and very important for you. Please keep remembering it. So now we move to the next slide to continue our discussion on determinant. So we have the determinant of a 3 by 3 matrix. We have seen the determinant of a 2 by 2 matrix. Straightforward, very easy. Now we're going to deal with determinant of a 3 by 3 matrix. How do we handle the determinant of a 3 by 3 matrix? Now let's look at the matrix A. Here, This is 3 by 3, so we expect to have 3 columns and 3 rows. So when the elements all are fully written, then we can see that we have 3 columns and 3 rows. We already explained that, so I don't need to spend much time on that. So here you can see, here you have column 1, column 2, column 3. Then you have row 1, row 2, row 3. So then you have 3 rows and 3 columns. So that's very important. Now, in finding the determinant of a matrix, we are going to use 2 different methods. One is a shortcut, but the main method is called the cofactor method. How do we find the cofactor method? Remember, in a matrix, please don't forget, the signs alternate. The first element is positive, this is negative, this is positive. We keep alternating the sign. The next one should be negative, positive. If this is negative, this should be what? Positive. And this will be negative. If this is positive, this will be negative, and then this will be positive. Now, this is how the signs alternate. So when you handle a matrix, the minor of a matrix with the sign attached, we'll call that cofactor. So now the cofactor method is what we are going to be studying here for dealing with a 3 by 3 matrix. So now we have this matrix given. I want to find the determinant of A. So now the first thing we need to do here, we look at the first element there. So now you can see you have A11, that's the determinant, A12, A13, and so on and so forth. These are the elements. The only difference between this and the main question is that here we use curve bracket, here we use parallel lines to represent determinant, that we are looking for a determinant. So now, we are now going to go further to see what to do next. So we have the determinant of A. How do we handle that? How do we take that? So we are going to have the determinant of A will be this element that I'm going to highlight now. Can you see that element there? That is the first element we want to look at. And I want to use the first row. And I want to tell you that you are free to use either row 1. Please take note, you are free to use either this row to find the determinant or the second row to find the determinant or the third row to find the determinant. We are free to use any of those rows. Then what if I don't want to use the rows? I can also use the first column or the second column or the third column to find the determinants. We can use any of them, but in most textbooks, authors and teachers, they use the first row as if it's a must, you must use the first row. I want to tell you, you are free to use any row or any column to evaluate the determinant. Having explained that, now let's see. Now, the first element you are seeing highlighted here now is we are going to find the minus of that element. We are going to find the minus of that element. How do we find that? So that minor of A11 will be the element that are left if I delete all the ones in the same row and column with A11. Look at what I mean. You have A11 is in the same row with this, A11 is in the same column with this. So if I delete all those elements that are in A11 and A11, the rows and column, what is left is the other one that is highlighted in green. So now that's what is left. So that is called the minor. So the minor of that of A11 should be what is left. And that's what you are seeing here. We'll now take this element here and place them as the minor. Then from the sign where we will talk about, we are told that the signs alternate. Can you remember? Yes. What should be the sign of A12? Of course, from that explanation, A12 should be what? Minus. So now, we're now going to find the minus of A12. How do we get the minus of A12? How can we get that? Minus of A12. Like I said before, you delete all the element that is in the same row and the same column with A12. So what is left? You have this and this left. So now this will be the element that we are interested in. So now, therefore, what is left will be this and this. So we are going to put that in the determinant symbol. So we have that. So that's the minor of A1, 2. While everything there together will give us the cofactor as we said. Now, then we move to the next one. Then, what should be the minor of A13? The minor of A13 will be what is left if I delete all the element that is in the same row and column with what? A13. Now, if I do that, this is what is left. So we now put all those elements in that square bracket. So now we have that. So now these are the cofactor method. This is what we refer as the cofactor method. So now that gives us the definition of the determinant or the formula to handle the determinant. Already a 2 by 2 determinant, we have seen how to handle that. Please subscribe, like the video, share the link of this video with others, and click for alerts. So now we are going to see what we are going to do next. So now, if I have this, everything we have done here is here, so I don't need to explain any other thing, just for you to see them put together. So you can see that's what we are saying. And everything we are seeing here is what we have done here. So now let's do some calculation. The first calculation we're going to carry out will be on using the cofactor method. So now let's see the question now. So now this is the question. Calculate the determinant of the 3 by 3 matrix. Calculate the determinant of the 3 by 3 matrix, and the determinant is given in the question there. Now that you have seen the question, can we move to the next slide so that we can solve this question together? Remember, we are working together. Now, to the next slide now. So that's the questions as a reminder. So we start. Now, what's the first thing we're supposed to do? We first of all represent that determinant. So now I have the determinant, then that's the determinant represented. Then I now find the minus of 7. Now, like we're going to use the first row as usual, but remember, as I said, you are free to use any row or any column of your choice, and your answer will still be the same. It's not going to be different. So now, what's the next? Find the minor of 7 by deleting all the elements that is in the same row and column with 7. So for 7 now, what do we have left? 0, 1, 5, 3. So these are the minors. So now we now write that out. We now write that. So now when we have written that, then we are going to find the next one. But remember, it's going to be minus, because if the first one is plus, the second one should be minus, the third should be plus, and the signs continue to alternate, right? Don't forget. So now we have the next one should be minus, and then we're now going to find the minor of 2. The minor of 2. The minor of 2 is obtained by deleting all the elements that is in the same row and column with 2, as you can see in this simple animation. So what is left? You have 2. Then on the right, you have 2 minus 3. On the left, you have 1, 3. So we're going to put them there. So 2 multiplied by its minor. Then the next one is positive, since the signs are alternating. So we have that. So now we have deleting all the elements in the same row and column with minus 4. Remember, since 4 is minus, so the final sign will be what? Minus. So now we have that. So we have all the elements represented. So now what we do now is we're going to expand this. We're going to expand this. So the determinant will give us then we'll find the determinant of each of those 2 by 2 matrices. The first one is obtained by saying this column, remember what we said. I hope you still remember. the leading diagonal is 0, 3 times 0. The second diagonal is 5 times 1. Remember, the sign for second diagonal is minus. If your multiplication is minus, then it becomes plus because the two negative signs will become positive. But in this case, they are not, so we have a minus because they are both positive. So now we have that. And then the next one now, that is 2 times 3. Then minus 1, minus 3, minus 3, minus 3. Look at this, minus 3 times 1 is minus 3. But remember that sign, that direction is what? Minus. So minus that minus will give us a positive answer, a plus answer. So that's why that answer there is plus. And then we move to the next one, then minus 4. This is 10 minus 0. So now we simplify that further. That will give us a minus 35. Then 9 times minus 2, minus 18. And then 10 times minus 2, minus 40. Now, put everything together. You are going to have your final answer as minus 93. Minus 93. So the determinant of that matrix is minus 93. So now that gives us that one. So now we're going to go to the next slide to continue our presentation. And then this time around, we're going to still be looking at 3 by 3 matrices using the second method, the Saros method, which is a shortcut, a short way, a short rule for handling 3 by 3 matrices alone. We cannot apply it for 2 by 2 or any other matrix, just for 3 by 3 matrices. So now the rule for Saros is, the Saros will simply state that if you are going to find the determinant of a 3 by 3 matrix by this method, first of all, you repeat the first 2 columns of the matrix to the right. Repeat the first 2 columns of the matrix to the right. Now, if you look at the matrix, this is the original matrix we have here. And then we're going to repeat the first 2 of this matrix. The first 2 is this. We're going to write that first 2 at the back of that original matrix. Is that clear? So that first 2 columns, write that at the back of the other, the last column of the original matrix. So having done that now, so we are now going to now drop our arrow. All the columns and all the diagonals that complete 3 numbers, we are going to take them. The diagonal, the ones, the arrows pointing down from left to the right are negative. And then from left to the right down, negative. Left to the right up, positive. So now, if you multiply them together, you have like that. Multiply this together, you have this. So now, then we repeat the same thing for up. Remember the blue, positive. And then positive. And then positive. So now, having obtained this now, we're now going to calculate the sum of all these multiply the rows, diagonals. So now you multiply if you add the sum of the one to the first one, they're going to have, that means these red ones. If you add these ones together, you have this, what we're having here. So now, then we are going to also add, then we're going to subtract the other ones too. So when we subtract that, after adding them, we have that. So now the determinant will be the first minus the second. The first minus, that means the left down is positive, right, left up is negative. So now when you do that, that will give you the determinant of that matrix. So now let's now take example. Time is against me. So now we now take the determinant, the same determinant again. We have the same determinant. We have the determinant, the elements now written down. So what do? We repeat the first 2 columns at the back. we repeat the first two columns at the back. So now we repeat those first two columns. I use different colors so that you can see it clearly. Then what do we do next? We take all the elements in the same that complete tray. So remember down, the red arrow is positive. So now you multiply all that. What will be our answer? Yeah, the determinant of that will give us 0 because 7 times 0 times 3 will give me 0. So now the next one, you have 7 times 1 times minus 3, 2 times 1 times minus 3. What would that give us? Minus 6. Then the next one, minus 4 times 2 times 5 will give us minus 40. So we write that, and then we complete the bracket for that, and then we minus the one that we're going to do now, the arrows moving from left upward. Then we have the blue arrow now. Minus 3 times 0 times minus 4 will give us, of course, 0. Then we now take the next one. 5 times 1 times 7. That will also give us 5 times 1 is 5, times 7 is 35. So plus 35. And then the last one that complete 3. The other one are not complete. They're only 2, 1. So now that one, if you multiply all those elements, 3 times 2 times 2. So what do you have? You have 12, of course. Then you simplify that. Then that means the determinant will give me the first one, add everything, minus 46, then subtract the second one. If you subtract the second one, that's minus 47. Then if you do that, minus 46 minus 47 will give us a minus 93, which is also the same answer we got using a cofactor method. So this shows that with these two methods works very well for 3 by 3 matrices. So it depends on your choice. Anyone you like to work with, that is your choice. Go ahead and work with that. So now remember to subscribe, like the video, share the link of this video, and click for alert so that you receive the next video when it is released. Let's move to the next slide and see what we are going to do. Now I say, given the determinant this is equal to 0, solve for x. Solve for x. You can use any of the methods. So I will be very fast because of time. I wanted the video to end in less than 30 minutes. We are now over 30 minutes. So now we have the elements. 0 will be equal to that. We eliminate. We now find the cofactor of 1. So we have the cofactor of 1. Then we find the cofactor of s. Remember, it's going to be minus s. And then you delete all the elements in the same row and column with x. That will give us that's what is left. Then you find the cofactors of what? 2. Then you have that. Then we simplify this. I hope I'm not too fast. Please work with me. So now we have that. We simplify. Leading diagonal is 3. The other one is 3. Also 3 minus 3 will give us 0. Then we move to the next, x times x minus 6. Then you have 2 into x minus 6 again. Then we simplify that by removing brackets and distributing the number or the letter outside the bracket. So we're going to simplify that to get, because you know the first one is 0. So the next one should be x squared minus 6x. But minus is there, you have plus 6x. And the other one is 2x minus 12. Then we simplify that quadratic equation. So now we simplify that quadratic equation. And then we rearrange that. We rearrange that, taking everything to the left side. Then you have x squared minus 8x plus 12 is equal to 0. Now use the factorization method. Use the factorization method. Please, time will not permit me to show you the factorization method. I know you have done that. So using the factorization method, we factorize this. So when you factorize this is what you are going to get. So now, having obtained that, then we are going now to say Either x minus 2 is equal to 0 or x minus 6 is equal to 0, giving us x is equal to 2 or x is equal to 6. So that gives us the solution of this x is equal to 6. That brings us to the end of this presentation. Please remember to subscribe, like the video, share the link of this video with your friends, click for alert so that you receive the next presentation. Thank you for watching.